reality. Caught in a landslide, no escape from reality.
What is the domain of this function?
I was just asking myself that same question.
Now, domain, sometimes students get domain and range mixed up.
Right.
I think. Which one is, wait, domain is the...
Domain is your input values, the
domain,
x values.
Domain is x values. I get that. Domain is the x values. Range is the y values, or the output. I like that. Input, output. I like that.
Yeah.
So domain is like, what can I put in for my x values and get out
Something.
some y value?
Yeah.
Now, you know, if I write f of x, you know that's the same thing as writing y. So I could just write y equals all this kind of stuff. F of x means what's y. So what I'm asking is, what x values can I put in here? Like, could I put in a 1 for all these x's, or a 2 for all these x's, or like a pi for all of them, or
I was thinking pi.
or e for all of them,
Or a -1/5.
or a 0.21987 for
Or
all these
0. You can put in all those numbers
I'm
for
thinking
x.
I could actually put in any single x value that I wanted to and get out a real number answer. There's nothing that I could put in here that would give me something that was not real, imaginary, so forth. You know all about imaginary numbers, of course. I learned that last year. So I'm going to say that the domain of this function is all reals. And you've seen that funny looking R before. That means I can stick in any real number I like, and I get out a real y value answer. And if I were to graph this thing, I don't really know what it looks like. It's some crazy function. But what does it mean, really, to say that the domain is all reals? What does that mean?
I guess that means there are no holes. I mean, the graph exists. There's some y value for every x.
Exactly right. It means that I could walk along, this is me, I could walk along the x-axis, and this function would exist either above me, I don't know what it looks like, it's some crazy function. This function would exist either above me or below me, I mean it could be anywhere, for every point that I'm standing. It exists for every real number.
Absolutely. So domain is all reals. But hey, what's the funny notation? You know, with the, right, but the other negative infinity, comma, infinity with a soft brackets.
We could do that.
Yeah.
We could say that this function exists for all x values from negative infinity to positive infinity. Usually they put that in
the
parentheses.
soft brackets, right.
Not the, because you can't reach infinity, it's not the square root.
Exactly. Beautiful.
Here's another function. What's the domain of this function? Again, when you're asked to find the domain, you're just asked to figure out what x values can you put in that will then produce some y value, some point. I always think, well, let's start with all real numbers. I could plug in a 1, I could plug in a 0, I could plug in 100. But there's actually one number that I cannot plug in or substitute in for x, because it will produce a problem. It will produce a 0 in the denominator. If you remember, it never makes sense to divide by 0, right? You can't divide a number by 0. That equals nothing, because 0 times nothing is 6. It's impossible. So I have to avoid 0 in the denominator, otherwise those math police are going to come and arrest me. So basically, my domain is going to be all real numbers except for the x value that produces a 0 in the denominator. Now, sometimes I can just figure that out of my head, or if you want, you can say, all right, well, let's see. I know that that 2x minus 5 cannot equal 0. You can treat it as a little kind of equation, if you will. Oh, if I divide by 2, x cannot equal 5 halves. So I can state that here, or 2 1/2, as my domain. Basically, I can plug in any real number I want to except for this one value. 2.5 is going to produce 0
Well,
in the
what
denominator.
about plugging in 0? Does that where I always get that mixed up, Miss Stewart? Can't I just stick in a 0? What'll that give me?
Yeah,
The
well, let's
original-
find out. Let's substitute in a 0 for x.
That gives me 0 on top.
On top, 2 times 0 minus 5. So that gives me 0 over, let's see, -5. Well, what is 0 divided by -5?
Oh, that's 0.
That equals 0.
Oh, so that's okay.
So that's fine. That's a value. value. That's your point 0, 0.
I
So
see. Wait, so 0
It's
on
actually
top,
plus-
that's okay. That's just 0.
That's just 0.
0 on the bottom, undefined.
Undefined.
Great, because you know what? That is going to come up again and again and again. So if you can like say that to yourself right now and be totally good with it, like 0 on top, well, that's just 0. 0 on the bottom, no good. That's undefined.
Yeah, and
That's a big one. That
Right.
comes up a lot.
And let's think why. If I pick a number, that equals 0 because 6 times 0 equals 0. That works,
That makes total sense.
right? Whereas the other way does not work.
It's fabulous, Ms. Stewart. Thank you.
Thank you.
This is the last one, Ms. Stewart. So hang in there.
I'm hanging.
So I want to know, what is the domain of this function? Now this is a radical, of course. This means square root of this entire thing, 4x plus 9. Now what's the deal with square roots?
Well, let's see.
Can I?
Yeah, if
Go
you
ahead.
take the square root of a negative number, you end up with an imaginary
That's right.
number.
That's that I business. isn't it?
I business.
Yes, I.
And
Remember,
since
I
we're
know.
dealing with functions, we want to stay in the real numbers.
Right. So whatever is under the square root, can it be 0? Is that all right? Square
Well-
root is 0. What's the square root of 0?
0.
That's 0. Right.
Yeah.
So it can be 0.
Sure.
But it can't be negative.
That's right.
So would it be fair enough to say that whatever is underneath here, in this case, it is 4x plus 9, must be greater than 0, but it can also be equal to 0.
Beautiful.
Can I just say that? Is that
I think you
reasonable
should
to
say that.
Okay.
That's beautiful.
So that's what I'm saying. So I think I can just solve for x now. I have 4x equals, I'm just going to subtract the 9, I'm sorry, not equals, greater than or equal to negative 9, and I'll just divide by 4. So I have x is greater than or equal to negative 9/4. That's my domain.
That's
I
your
am done.
domain. You're done. In other words, any x value that's bigger than or equal to negative 9/4 will give you a y value.
That's right. And if I pick something less than this, I'll get a negative under my radical, which will mean I'll have an imaginary number.
Fantastic.
Absolutely.
So if I were to graph this, what would it look like?
Yeah, that's a good question. Well, what that would mean, can I walk along my graph again?
I think you should walk around along your
Yeah,
graph.
thank you. That would mean that as I'm walking along the x-axis, looking above and below me for the function, I would not see that function until I got to negative 9/4, which is a little bit more negative than negative 2. So negative 1, negative 2. I'm walking along, I don't see anything, and then all of a sudden, I see my function starting here at negative 9/4, and it exists for all values greater than that.
Very nice.